Eric, you've been working on a project about generating time estimates for PCB layout. And I guess before we kind of get into the meat of that, I'm actually just wondering what caused you to start working on this.
I found myself in a work environment. We were doing a lot of government contracts, and I was surrounded by a lot of really technical people. And when the question of PCB layouts, came up, I heard people going off a lot of like assumptions and misconceptions and things that just really weren't true. And, as I delved into it, I realized a lot of people out there really don't know a whole lot about, what goes into the PCB layout process.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson. Today, we're talking with Eric Penchansky, electrical engineer and PCB designer, and Lauren Waslick, director of PCB design at Newgrange Design. Eric's been working on an interesting project that helps design engineers estimate the time and effort required to lay out PCBs. And we're going to be talking with Eric and Lauren both about this new project and how it can help you out. Eric, Lauren, thank you both so much for being here today.
Thanks for having us.
Yeah, absolutely. So I think you both are new to the podcast. So if you could, if you just tell us a bit about your background and how you got into the PCB design world. Lauren, why don't you go first?
Sure. So I have been at Newgrange Design for about 12 years, for many of those as a PCB designer, and then I moved into the director role where I oversee our team of about 30 designers. And I sort of got into PCB design on chance. I was a mathematics major in my undergrad and found a company that was training from the ground up in this new field in electronics, which seemed really interesting. So I decided to give it a go, and it ended up being a really great fit and sort of haven't looked back since.
Eric, how about you? Tell us about your background.
I had started working in R&D after getting out of engineering school, and a few opportunities came up where I had a chance to design a PCB and learn from people with a lot more experience than me, and I just took a liking to it. I couldn't get enough of it. I love the puzzle solving aspect, which if you're somebody who's into it, PCB design is the ultimate puzzle solving challenge. So
I would agree. I think it is the ultimate puzzle solving challenge. So what kind of designs do you guys normally work on?
Sure. So I happen to be working in robotics and automation. So type of projects that come up might be involving power management, motor controls and such, some communication protocols. And we're starting to delve a little bit more into the world of high-speed digital design. More and more, everything's getting faster. The company I work with has roots in the automotive industry, and they're really starting to get into the really high-speed stuff. A few months back, I was helping out a colleague with some 10 gigabit Ethernet layout challenges. So it seems to be the direction things are heading in.
And then Lauren, how about you?
Sure. So since I work at a service bureau, I work on all different types of designs, which keeps it very interesting. We work across all industries, a lot of medical, consumer products, defense, robotics, among many others. Also lots of different sort of standards and protocols from those different industries. And we also get to work on, prototype production, different things like that, as well as different circuit challenges, high voltage, high current, rigid flex, HDI, all the fun stuff.
So we have some diverse perspectives here across the two of you, both in terms of types of designs and then I think industry focus. So I think this is germane to the next point, which is, Eric, you've been working on a project about generating time estimates for PCB layout. And I guess before we kind of get into the meat of that, I'm actually just wondering what caused you to start working on this.
So this was something that came up a few years ago. I found myself in a work environment. We were doing a lot of government contracts, and I was surrounded by a lot of really technical people. And when the question of PCB layouts came up, I heard people going off a lot of like assumptions and misconceptions and things that just really weren't true. And, as I delved into it, I realized a lot of people out there really don't know a whole lot about, what goes into the PCB layout process. What factors actually do matter and what stuff really doesn't matter so much. And so that's what drove me to start creating this document initially. And as I got further into it, I said, well, maybe this can help people that are designing as well, because there's so many different things to try and keep tabs on as you're, estimating. And a lot of stakeholders like, we need an answer now. We want numbers. We want to know, will this be done Tuesday? Will it be done on Wednesday? And so that's what drove me to start putting this together, to get those ideas that I had learned from doing it myself and learning from other more experienced people in the field doing this, getting those ideas, getting us asking the right questions, and putting away some of the myths and misconceptions, in in hopes of creating a tool or reference guide, something that can be distilled into a checklist that people can use. And maybe it's not the definitive answer, but at least asking some of the general questions, getting them thinking about those sorts of things. And as I started putting together, I started reaching out for feedback from different individuals. And last year, I was finally able to get some feedback. I had taken this PCEA course, the CPCD class with Thomas Chester, and I was able to share a document with him. And he gave me some really interesting insight about asking the stakeholders to describe the project and see, how they would articulate the requirements. And if they're having a hard time putting into words, add that into your time estimates right there. And I happened to meet Lauren at most recent PCB East, also a PCA event. She was giving a talk on, Flex PCB Design. And we got to chatting before the event. And she liked the idea, and we, ended up reconnecting some weeks later. I shared the document with her, and she got back to me. I had no idea what sort of response I would get. And it was almost like, wow, there's somebody else out there that actually gets it. So that's where I got the idea, okay, well, maybe this would have some value to other people out there. And so we were talking and brainstorming, how can we get this information out to people? And I think that same day I was listening to the OnTrack podcast, and that's where the idea, let's see if Zach would be interested in taking on the call. Lauren, you want to share your side of the story?
Sure, yeah. That, the same thing that Eric said when he mentioned this project to me at PCB East, and then we reconnected. I, read through it, and I was like, yes, somebody gets it. I had that same sort of moment because, I see this all the time in quoting our projects. We're quoting multiple projects a day generally throughout my team, and it's very, very hard, arguably one of the most difficult parts of the process, because there are just too many variables to consider and too many things you don't know. There will inevitably be things that come up along the way. And so a lot of times the gut instinct to say, well, this many parts and pins, shouldn't it be this many hours? It generally, there's many other things that kind of have a bigger impact than you might expect. So it was really great to connect with Eric on that and sort of talk through some points and relate to someone going through similar challenges.
So you guys brought up 2 points here. One of them is, parts and pins, and I think we can get into that in a moment. But another point here I think that's really interesting is the perspective, because Eric, it sounded like your perspective was kind of like as the internal person, and you've got an engineering manager who's maybe overseeing what you do, and they're trying to manage their projects. And then Lauren, you're coming at it from the perspective that I'm a little more familiar with, which is you have clients, you're trying to cost something out, give them a lead time, and you want to give them something realistic and that's going to entice them to buy. But you maybe you want to make sure it's fair to you as the service bureau, and you also want to make sure that you can justify the potential sticker shock that a project is going to bring. So where do you see any discrepancy between those two perspectives?
Sure. So in the context of where I might be laying out a PCB, some of the stakeholders involved, you have your, engineering, manager, maybe a project manager. You probably have some mechanical engineers that you're working with. They want to make sure that their enclosure is going to work or that your board is going to fit the enclosure they already designed. Sometimes the mechanical is driving the electrical, sometimes vice versa. And there may be some folks on the team who are dedicated to developing the firmware or embedded software if the electrical folks aren't handling that. So they want to know timelines as well, so they can plan their work and make sure that they'll have enough time to do what they need to do, and other stakeholders aren't blocked. And they can, the folks managing the project can plan timelines. Okay, so this is when we're going to have a minimum viable prototype or product that an end user customer could test out. And so that's the perspective that I find myself in when I'm designing these boards.
Yeah, I think there's kind of an assumption that the engineering managers should have some idea of this kind of stuff already and shouldn't place unreasonable expectations on maybe time requirements to get something done. Usually you're salaried, so maybe the money is kind of, secondary, but definitely the time aspect if you're working for a company, because I know that a lot of, especially like manufacturers, they're developing a product to bring to market. Sometimes those schedules can be really unreasonable.
Absolutely, yeah. And a lot of times, like as an engineer, you may have a manager who has a different technical background. So as you're communicating, you're also educating, okay, this is what the process actually entails. So they can set realistic expectations for, okay, do we have enough labor to cover this? Should we bring in more resources? Could we get some support with this, that, or the other thing? That's part of it. Like you're not just like communicating, but you're also like kind of educating them on that as well. And that's a big piece of it.
And then switching gears, Lauren, with you dealing with more customer facing and trying to convince somebody to buy the design services from you, how often have you had a client or a potential client come back and say, wow, I didn't expect that? Maybe they have this idea in their head that, it's going to take a few hours and they can farm it out to, somebody in India and pay a few $100 for it. And then they're, taking over the world with this new device. And the sticker shock probably just blows them out of the water.
Right. Yeah. So a lot of the conversations we're having, sometimes they're about timeline, but a lot of times it's about cost. And particularly when we're working with someone for the first time. Generally, if we've worked with a customer multiple times over and over, if they keep coming back, it means they're liking the service they're getting and they're understanding that it's worth the value they're paying, and they start to trust us and say, yeah, we know you, whatever it takes, just do it. But when you're working with someone for the first time, it's a very different conversation of they don't trust us yet. We want to get them to trust us, but sometimes that sticker shock can be a lot. And I think the biggest thing that is surprising to them is that the specific number to place and route the board is not the full cost of the design. That's the middle piece, which is the fun puzzle solving part we all love. But there is the input and the digestion and the discussion and the schematic comprehension and the questions to really understand what are we working with, what's our mechanical constraint, is the mechanical constraint ready yet, or is it still changing? Is the schematic fixed, or is it still changing? And then once you digest that, you have to work through the library and the footprinting request, which sometimes can be an extremely high piece of the job as well. Then you do the place and route, and then there's a whole output side of the job with the DFM, the DRCs, the file generation, the checking of the files, the back and forth with the fab house that really can add a lot, but it's really going to add a lot of value. It's going to really reduce risk and give you a better board. So some people are willing to put in that effort, and some people it causes the sticker shock.
So a little follow on to that. I have found when working with a client that when you outline some of those tasks to them, they have this idea, well, I'll just do some of that stuff myself, and that's going to cut my cost with you in half or in a third, and then they try and negotiate you down. Have you ever had to deal with that and then come back and explain to them some of the points that are in this document?
Yes, absolutely. There are some pieces. I mean, sometimes customers are handling maybe their library work internally. They've got a system in place for that works for them. Great. If they trust their footprints, we'll trust their footprints. If they don't trust their footprints, we'll help them with that. Also, sometimes we'll get boards that are already placed and they want us to just route. However, generally we will do a bit of review as we're routing, because if the placement isn't as logical as we would have done it, it's going to make the routing harder. So you really need to start with a good placement to have efficient routing. So even if the placement is done, that doesn't always save a ton of time, because we'll still want to make sure, like, did you place your switching power supply correctly? Because if you didn't, then it's not going to work. It saves you a little time and it causes you a whole respin. So it's really not saving you time or money. So we have that perspective, and we have to a lot of times explain that. And again, after you build that trust, it's easier to get across. But sometimes people learn the hard way, and sometimes we can help them learn the easy way.
Yeah, those are great points. Now, on to the second thing that I think you both mentioned, which is the estimate time and how that relates to part count and pin count. I think there is a bit of a perception that you should just charge a fixed number per pin or a fixed number per part. And that's how much you should charge if you're doing, design services, or maybe if you're, developing a schedule, you work at a company, it should take a certain, number of hours or minutes or whatever per part, per pin. What do you see as being wrong with that? I can give you my opinion, but I want to hear from the both of you.
I mean, there's just so much more to it than that. And I think part of it is how you, educate your stakeholders on that process. I think that's important, but there's just so many other pieces. And, just going through this document here, some of the bigger pieces, and I know Lauren was really expanding upon the human factors element and the state of the library, which is extremely critical. And another piece that we were really looking at is what's going to be on the board. What sort of subcircuits, what sort of, design areas do you have to be cognizant of? Are we going into RF? Are we dealing with high-speed digital? Are you dealing with flex design? Does it have to be IPC class 3? Are you dealing with components with fine pitch, high pin count, backplane connectors? Are you going to need to use, HDI or ultra HDI or advanced manufacturing techniques? So these things all really weigh into it, and can definitely impact the design time, because you have to be a lot more cognizant. Okay, now I have to make sure I'm impedance matching and I have controlled impedance here. And if not, it's not just an EMC thing. The circuit might not even work. So yeah, there's a lot. And also if the boards are like, okay, yeah, we want to do emissions testing with the first prototype. Okay. All right. That means you're going to have to put a lot more work to getting everything just right on the first go. So I think that weighs a ton on the design. Lauren, would you like to expand upon that? I'm sure there's a few bullet points I might have missed.
Sure, yeah. So I absolutely agree. I think there's just too many other things going on. Pin count is one relatively important, but also, just one piece of the puzzle that is great in theory, and it would maybe make sense doing a cost per pin in a situation where you're an internal designer at a company and you're designing different flavors of the same test board over and over and over again. You get a pretty good idea how long it's going to take because you've done pretty much the same thing already. But in most situations where you're designing a motor driver one day and a high-speed memory circuit the next, and then a small LED board the next, they're not comparable in that way. They have, different, the mechanical is going to be different. So the same number of pins with twice the space is going to be easier. The space is a big piece of that puzzle. What is there a BGA, and what's the pitch of that BGA, and what's the current? Is there 70 amps that you have to deal with high copper weights and bus bars and things like that, or is it, or is it standard technology? So it's really, there's just too many things that when you're talking about a diverse array of boards, that pin count is not going to tell you enough information.
My perspective on some of this has been that I would agree pin count doesn't tell the whole story. I've looked more at net count, and you brought up BGAs. On some BGAs, if you look at the bottom of it, the majority of those pins might only be assigned to like 4 or 5 rails because they could be power and ground, right? You might have, let's say, 4 power rails and then all your ground pins. Then you could get into like a BGA, but maybe it's an FPGA, right? And so now you've got a much higher diversity of pins. And so even though they're the same package, the same part, that diversity of different pin types on the 2 different components really throws off the estimate between those 2. So I think that can be a little bit of a shock to somebody who's looking at a design, and then, you say, well, yeah, they both have BGAs, but, this one takes an extra, I don't know, week or whatever to finish routing due to the diversity of pins. What do you guys think of that argument?
Absolutely. I think that would definitely be a factor. The diversity of the pins on the BGA, not just the fact that there's a BGA, but like you said, some of those are going to be a lot more intensive when it comes to routing. And so it's nuanced. It's very nuanced, and somebody who doesn't lay out a lot of boards or doesn't have, doesn't really have a whole lot of familiarity with the territory, they might make an assumption on that. And so, yeah, that's a really important point. Lauren, what are your thoughts on that?
Yeah, I think the number of unique nets on the BGA is going to be really important because it's going to drive your breakout and your layer count and your via technology as well, along with the pitch of the BGA. Can you use through-hole vias, or do you need the blind and buried, which adds a lot of time. And then usually when you have more unique signals, you're also dealing with controlled impedance and length matching, which just adds a whole nother level of complexity and time into it as well. So there's a lot of questions to ask with the BGA.
Yeah, I think the BGA is always the one that throws a wrench into things, because if you had the same net count, let's say same part count, same net count, but maybe it was, quad flat package instead of a BGA, the design approach would be totally different. Mm-hmm. And therefore the layout and routing approach would be totally different, and that affects the time. And then if it's a service that you're providing, it affects the cost.
Yeah, absolutely. And I think the next big item after that is the mechanical as well. It's how much space do you have? Do you have the top and bottom completely loaded with components? So we talk about that in terms of pin density, to say the higher that density, the more difficult that breakout and finding spots for vias is going to be. So there's the mechanical is sort of the next big thing in my point of view.
Yeah, I've found that the mechanical, or maybe forgetting about the mechanical constraints or not having them clearly defined, allowing them to change, that's probably for me the number one thing that forces redesigns and then adds to the time and ultimately the cost of the project. Eric, I see you nodding your head here. What do you think about that?
Oh yeah, that comes up all the time. I was actually looking at a board today. It was designed by somebody else, but it was clear that the board was designed after the enclosure was designed, because it was nearly impossible to get this thing out. You had to take apart half the prototype just to get it out. It might have been, oh God, at least an hour to get this thing out of there. There was ring lugs. It was a lot. So yeah, the mechanical is a huge piece. And one thing that I want to expand upon is, when we talk about the features on the board, if those features are going to require some advanced manufacturing techniques, some of the more avant-garde stuff, the amount of time that you're going to spend trying to vet your PCB vendors is going to be a lot longer, because you want to make sure that they can handle that they're comfortable with it. They may be able to handle some things and not other things. So I think that definitely plays a big factor into it too, that vetting process for the manufacturers becomes much more involved as you get into integrating these more, these more exotic features, I guess you say. I don't know. I have a better word.
No, I get the gist of it. And I think this is another area where I think, Lauren, maybe you have some perspective on this, where maybe if a customer is paying for a design service and you inform them, hey, this is going to require a more advanced process because of the components you've chosen and, on down the list, they probably have this perception of, well, wait, can't I just send this to China and anybody can manufacture it? Why do I now need to have another engagement with you just to find somebody who can manufacture it?
Yeah, absolutely. It's one thing we're constantly trying to encourage our customers to do is identify and build a relationship with your fabrication resources, because you really want to understand their capabilities. And maybe you have multiple, maybe you have one for prototype, one for production, and that's completely fine, another for rigid flex. But you want to make sure you're building those partnerships. And as designers, we love to talk to them at the beginning to make sure we're getting their input on things like stack up via technology, um, just overall capabilities of their standard and advanced, because we want to make sure that what we're building in is going to be able to be built at their site. If our customer's undecided and we're making our best guess, we try to go more conservative. And when we need to go advanced, we say we should really bring in a fab house now, because we don't want to give you files that get turned away from somewhere that you send them because we've assumed more advanced capabilities than what is possible. So that relationship and bringing that piece of the puzzle in as soon as possible is really going to help in the long run get you a better first rev of your board, and a quicker first rev, because you won't have as much DFM and you'll be able to sort of build as soon as the board is done. But yeah, that can be a huge piece where if not everybody is on the same page, that's a huge thing we try to push on our customers, is make sure you're talking to your fabricator, make sure we are in contact with the mechanical designer, electrical, anyone from test that we need as well, just to make sure all pieces of the puzzle are built in from the very beginning.
So shifting gears here for just a moment, if you guys think back about your experiences here and maybe think back about some of the designs you've estimated that were maybe not in the ballpark of where they needed to be, what do you think are some of the most common points that people can forget or overlook when preparing a layout time estimate or a layout cost estimate? Eric, you want to go first?
I think it's definitely the starting point is a big factor. Some people may assume that, okay, maybe we're just respinning an existing board, adding on some new features, so that's just going to be trivial. Or they're not really looking at what those features are, what those changes are going to mean. They might assume that, okay, maybe this is going to be quicker or easier, or we're not going to run into issues. Or they might, it might be an overestimate too. So that's an area that comes up. Yeah, those are the first ones that came to mind for me.
Sure. So one of the biggest impacts is what Eric mentioned earlier, is the human factor, as I like to call it, where it's different working with every person, especially so at a service bureau. You could be working with multiple different companies and engineers a day, and their working style, their communication style, their preferences, their thoroughness of their reviews is different. The number of people involved, sometimes we've got 10 people on the email chain all giving us replies, and their replies are inconsistent with each other. So then we have to say, we've got a few different pieces of input here. Which one should we follow? As opposed to a situation where the designer and engineer have worked together over and over, and they sort of can think 2 steps ahead from the other person's perspective. That can save a ton of time when you've got that good working relationship. And the first few jobs can be working out those kinks of understanding, what exactly do you think I am responsible for? What are you responsible for? Who's providing the final stamp of approval on this? How many rounds of review is this going to go through? And when we send you final route review, is it going to come back with a week's worth of edits or a day's worth of edits? We don't know that when we first work with a customer, but after we run through a handful of jobs, we understand they usually give us X amount of feedback on this type of board, so we can quote that a lot bit more accurately. So a lot of time the beginning is just learning how to work together and really understanding what that other person's working style is and communication style is, so that we can help tailor and learn from that and just improve in the future boards.
I like that you brought up the human element, because I have definitely experienced that. You get a new, let's say a new customer, and their level of, I guess their level of detail that they pay attention to can be very different from the last 5 customers. And I think it can be a little bit of a shock because it definitely adds to your review time, your collaboration time, the amount of time you spend replying to emails, let's say. I think all of that factors into it. But looking at it from maybe, you're working at a company and, you're an internal employee. Do you think that's any different, Eric? Do you think there's any kind of human issue that's really hard to anticipate?
So if it's a stakeholder that you haven't worked with before, you got to factor that in because everybody has different communication styles, and may have different ways of communicating or may make certain assumptions. One thing that I've noticed is that when you have two people who have worked together for a very long time, they don't realize how much of their communication has become implicit. Things that might have been an elaborate explanations, like a one-word thing, or they're like reading each other's minds, and then all of a sudden, this third person comes in that don't know that implicit language, and they're like in a world of like shock, whether that's the designer or the person asking for the board. That's a huge piece, the communication element. And one of the things that I've, tried to figure out over the years is like, is there a means of being able to evaluate the effectiveness of communication in, an objective manner? And the thing that I've started looking for in terms of like gauging successful communication is the absence of surprises. The less surprises there are, generally, it means there's better communication going on. That's the metric I tend to use. And anybody asks me, I'll preach it. When no one's saying, "Wait, what? Hold the phone. What did you say? What? Why didn't you tell me about this thing?" That's what we're trying to avoid. And I'd rather share the news, even if it's less convenient news, up front than have, those surprises,
So I think before we wrap up, Eric, you mentioned that you had shopped this around to some other folks. I mean, Lauren here, of course, included. In your time shopping this around and getting feedback, what has been some of the feedback you've received about this document and maybe how far and wide it can be distributed and how people can digest some of that information into their own process?
Well, one thing that I've come to realize is because initially I was just shopping this around to coworkers, and I don't think it was anything personal. I think it's just people are so busy at work, they don't really have time to look through stuff like this. They're just like trying to get through their day and get home at a decent hour. And it wasn't until I started reaching out to people within the PCA that I actually started to get some feedback, that people started to engage, say, "Oh yeah, those are some good questions. I was thinking about this, that, and the other thing." That's where the rubber hit the road for this. And I think going forward, that's kind of a pathway. So getting more input. And Zach, I'm really grateful that I could get some of your insight here too, and share this. And I'm hoping that as time goes on, we can get input from more members of the PCA and folks who are heavily engaged in this type of work.
So, Lauren, I'm going to give you the last question. So, as someone who's director of PCB design, implicitly you're overseeing a team of people. How do you see a method to include a doc like this or portions of a document like this into your own process, and how do you then take that and use it to, I guess, manage your team and produce better outcomes for clients?
Yeah, absolutely. So especially at Newgrange Design, we are doing a lot of full training of designers from the ground up. So we're sort of teaching them the basics of footprinting all the way through complex design. And in that, we need to teach them how to quote designs and how to interpret input files from customers and understand the how complex the design is going to be out of that. So quoting is one of the most difficult things we have to train on and teach. It takes a while to really feel confident in an ability to quote, and even when you are confident, sometimes it's way off. It's just how it is. But the points that Eric outlined in this document are really could be really helpful for sort of training our team on questions to ask the customer, how complete is the input that you're giving us and how many changes should be expected, and just also doing some education on our customers to say, here's why quoting is challenging. We've done this a lot. We've quoted a lot of boards. We usually do a decent job, but there are situations where it's not something we've seen exactly before. It's got very unique challenges, or there's something unexpected that comes along the way. So I think this internally could be really helpful to continue to train our team on how to interpret input, how to talk to customers, what questions to ask, and also to just understand, yes, this is hard. It feels hard to quote, but it also, other people agree this is a hard piece of the job, because it can just take a while to get comfortable, but also using it as a tool of communication with customers to explain why part and pin count isn't necessarily going to be the best predictor of overall design time.
Okay, that's great. That's great to hear that you can see some ways that this is all applicable. Eric, Lauren, I want to thank you both for being here today. Eric, quick question for you. Are you okay if people get a hold of you on LinkedIn to maybe ask you about this document and maybe take a look at it, give you some feedback, help distribute it?
Absolutely. Yeah, I'd love that.
Okay.
More input, the better. I think as a field, we grow together by sharing knowledge. So I'm all for it. Absolutely.
100% agree. And if anyone is interested in doing that, make sure to check out the link in the video description. You'll be able to get in contact with Eric. Or if you're looking at the show notes right now, go ahead and check out the links in the show notes, and you'll see a link to get a hold of Eric. Eric, Lauren, thank you so much for being here today.
Great. Thank you so much.
Thank you for having us.
To everyone that's out there listening and watching, we've been talking with Eric Penchansky, electrical engineer and PCB designer, and we've been talking with Lauren Waslick, director of PCB design at Newgrange Design. If you're watching on YouTube, make sure to hit the like button, hit the subscribe button. You'll be able to keep up with all of our podcast episodes and tutorials as they come out. Make sure to check out the show notes for any important links. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.